Hello folks, welcome to the Night Sky Imaging YouTube channel and Facebook page. If you're watching it on Facebook, if you have a question, I'll try to catch those. They should come up on my comments. I see Xavier K. Major is just logged on, and hello Xavier, and on YouTube. But if you're in for looking at Saturn and Jupiter, we're going to be doing that in a few minutes, and we're also going to be starting an imaging session where we're going to be adding more data to already did that one, Messier 16, which is the Eagle Nebula. Before we get started, I want to take you outside, and I want to share this screen. Hang on just a second, and if I can do it, and we'll take a look at the gear that I'll be using. I'm going to log on. I hope it works. This telescope right here, which is the wide field telescope, will be imaging M16, the Eagle Nebula, and it has a 333 millimeter field of view, so it takes a pretty wide swath of the sky, and it'll take in a lot of nebulosity that's in the Milky Way. This telescope though is going to be for the planetary images that we'll take of Jupiter and Saturn, and in contrast to 330 millimeters, this has over 8,000 millimeters of reach. So it has a very narrow field of view, but it does make for pretty sizable targets of both Jupiter and Saturn. I will not do any processing tonight, but what I wanted to do is I wanted to show you PixInsight, which is where I will ultimately add the data that we take tonight for the Eagle Nebula. And I'm going to bring up the hydrogen alpha, and I'll show you the data that I have so far. There's the Eagle. It's not properly oriented. If I could turn this clockwise 90 degrees, it would be properly oriented, and I'll do that before I finish processing. That's what the HA looks like, hydrogen alpha. This is what the sulfur looks like. You can see a lot of nebulosity, a lot of sulfur gas emission coming through, and then oxygen, not as much, but there is some rich oxygen which will show blue, kind of a teal color, and it's in the center part where the Eagle is. So we need more data, so we're going to go and get some. We're going to start with that telescope, because once I get that set up and running, then I can forget about it, and we'll just go over and play with the planets. So let's get started. I'll bring up the window for that telescope, and we're going to go find the target first. It's at RA 18 hours, 19 minutes, and 3.28 seconds, and the declination address is minus 13 degrees, 56 minutes, and 6.26 seconds. So that address never changes. It's the exact same address 365 days a year. So if you just typed in this address and ordered your gear to slew to that, then it should be reasonably close. If you start out with the mount properly polar aligned and aligned with the stars. So let's slew there now, and let's get set up. Let's go back and look at the outside camera, and why aren't we slewing? Let's go back. Oh, that's why. I had to unpark the scope. Now we'll go back and we can watch the telescope move in the direction. By the way, there are not lights shining on my gear. That's infrared light, and that's perfectly okay. the camera that's emitting the IR light is located on the fence, and I will never be imaging the fence, so I don't have to worry about that light going down the pipe. So we are going to now center. We slew to the nebula, but we're not centered. So we're going to plate solve and center. And this is the plate solving process where it takes a picture. It compares the picture that it takes with a catalog with precision location, and it will instruct the mount to move if it's not properly centered, and it won't be. As a matter of fact, it's 1,246 pixels off in right ascension, and it's 236 pixels off in declination, and I've instructed my software to get within 50 pixels, total pixels, in both RA and DEC. And so we did. It had to do it twice. We're 14 pixels off in RA, and we're 1 pixel off in declination. My camera's wanting to go to sleep to save power, but we're going to keep it on for a while. So we don't need to run that again. I want to immediately open up the PhD software, and I've already connected my gear. I'm going to start looping, and there are some stars, and I'm going to start guiding. So we are now guiding, which means that the telescope that rides on top of the main scope is taking this picture right here, and it's got a bead on this star, which is represented right here. And if the telescope does not stay right on that star, it sends instructions in the mount, and it makes corrections. Guiding helps to keep your gear pixel on pixel throughout the night while you're imaging. The mounts are not perfect, and there's slop in the gears. There's lots of issues that these mounts have to deal with, and so for that reason we're in need of having some guiding software and a guiding camera and telescope to help keep this thing on track. So now let's go back to our acquisition software, and let's go ahead and run the sequence. I've already connected all the gear, the camera, the filter wheel, the focuser, the mount, and we're connected to the Pegasus Astro Observing. We're using a Pegasus Ultimate Power Box, and this connects the power. I don't need a flat panel, but it's turned on. I can turn it off. The mount's connected, the focuser and the camera, and I can connect to my USB ports because the hub takes both data and power, and it is a hub by which everything's plugged in. So I can see what's going on. I can see the graphic of the power, how it's being used in voltage and amperage. This is also the, this is no surprise, but the temperature and the dew point have already intersected. So I'm going to guess that all my dew heaters are going full power, and they are. Here are the dew heater for the main camera and the dew heater for the guide camera, and it tells how many amps it's drawing. So real helpful software to see what's going on with your both data and power when you're imaging, particularly if you start getting some crazy things happening and your let's just say your images aren't downloading as fast as you think they should. Then you can check the USB port and see if there's something crazy happening. Okay, so let's go ahead and run the sequence. We have cooled the camera to minus 15 degrees Celsius. It's not minus 15 degrees below zero. It is minus 15 degrees from the ambient temperature. And it just so happens, let's bring up Pegasus. It just so happens that the temperature is 77.9 degrees. And Oh, that's the dew point. The temperature is 78 degrees, so we're probably somewhere around 65 degrees. The sensor's around 65 degrees right now, which will help mitigate some of the noise that comes from the thermal release of energy when these electrons are captured, particularly with your long exposures. Right now what we're doing is the automatic focuser automatically comes up, and it's going to run an automatic focus routine using the hydrogen alpha filter, because that's we're first going to run the hydrogen alpha routine, and then when that's done we'll run either, I don't remember what comes next, it's either sulfur or oxygen, and but we'll cycle through all three of those filtered images. And also, if I have set the parameters with my kit that I want to refocus for every 2-degree temperature change, whether it's up or down. And what happens when the temperature does change, it affects the inside of the telescope and the optics. And so you may be in focus currently, only to find that within a couple hours you kind of lost that sharpness, and your half flux radius has gone from a great number to a not so great number. And I'll show you what I mean by half flux radius. Let's go to image statistics. Well, I can't right now because this is running. And as soon as we get this imaging, which will take a few minutes because we're going to have to sit and just watch this autofocus routine do its thing, then we'll get this going, and we'll only stop by and take a look at some of the pictures as they're coming in when we start the imaging of Jupiter and Saturn. We're going to start out with Saturn. It's higher in the sky right now, and that's a good thing. Okay, the quality so far of the image run is at 98%. I'll take anything above 90%. As a matter of fact, I've set the parameters here that if it falls below 90%, it automatically runs another focus routine. And there's been times when I've sat here and watched this go through the focus routine 4 or 5 times in order to get it right. In fact, it's gone to 91%. But it's taking different images at different, it's moving, it's adjusting the focuser. It's moving it so many steps out, and it's moving it so many steps in, and it's taking pictures, and it's looking for an intersect. The algorithm is going to define that intersect as the sharpest focus point given the temperature of my sensor, camera, outside, inside. We're looking for a nice V curve, and that's what's happening. We started by focusing out. Now we're back to focusing in, and we're taking 15-second exposures. I think they may be longer. You have to take longer exposures when you're doing narrowband, because the bandwidth by which light comes through to your sensor is so narrow it restricts all other light, which makes it good if you're in the midst of a lot of light pollution, because it keeps that from messing with your images. Ooh, I hope we don't have to do this again. If we get a bad reading, I'll just go on. I'll let it run itself, and I'll go on over and start the other telescope. We won't sit here and watch this do its thing until absolutely drive me crazy. You get so impatient. But it does beat having to go outside and fiddle with the focuser and a batten-off mask in order to try to get that good focus. I don't think it's going to work. Anyway, it's saying that the position of steps, 10,953 steps. That's how far, that's how many steps, which is just a small micro movement of the focuser. It's measured in steps. That's how many steps it is from being racked all the way in. And the half flux radius is 3.4, which is terrible. Well, it got a 90%, so with a half flux radius of 1.75, that's much better, and that's good. I'll accept that. I probably would run it again where I'm not doing this thing live, but unfortunately, we're going to just deal with this, and I think it'll be just fine. But each time you run the focus routine, you're going to get a different set of numbers, and it's just a few steps, and it may just be just a few steps, but that few steps can make a big difference. I'm going to hide that just for a minute, and 1 second. I'm going to go to image stats, and you can see where the half flux radius is 1.76. Something that's important to note: given my camera, given my telescope, given my everything in the optical train, the seeing conditions in my neck of the woods right now is 1.76. There is absolutely no difference. The half flux radius equals seeing, and it's hard for me to explain because seeing becomes such a difficult concept for a lot of people to understand. But when you're doing these automatic focusing runs, it's measuring these stars in the sweet spot. And I call it the sweet spot, but you see this boundary going around? This is about 20% of my sensor is exposed to these stars. Primarily I do that because a lot of the stars out of this are not perfectly round, and I don't want that. It's because of the optics. I just want the optics that are in the center part of my telescope, my camera sensor, to be used for calculating the good focus run. So that's it. But the difference, 1.76 actually means is that right now it went up to 1.81 on the stars in this field, and that means that my kit right now could resolve a binary star, which is really two stars, that we could actually see two stars that were 1.81 arc seconds apart. So that's pretty cool. This is our first image. I'm going to stretch it a little more, and that's the Eagle Nebula. I've brightened it up some, which kind of looks like we've blown it out, but this is using the hydrogen alpha filter. And so what we're going to do is we're going to take, I've got 30 pictures that I've taken already, and you saw the results of that when we opened up PixInsight. We're going to take another 30, then it's going to rotate to the sulfur filter. We're going to take another 20, then oxygen, and we're going to take another 21, and we will have that the night in. It's going to take 2 hours and 39 minutes to run this sequence, so it will be somewhere around 1 o'clock when it's done, 1:30, given dithering time, filter change and focus times, and so it'll take more like 3 hours plus to run this, and then it will automatically park. It will have to do a Meridian Flip, and that means that when the weights get higher than the telescope, you want to flip them out. And so right now the mount is west shooting east. That means that the telescope is on the west side and it's shooting towards the east side. When we flip the mount, then the telescope will be on the east side shooting west. And that's going to happen when? I don't know. Pretty soon though. The transit's going to happen at 10:30, and that's when, if I may still be on, well, probably still will be online, but that's when you can see the weights are getting pretty high right now. And what's going to happen when it flips is that this is going to swing over and be on this side, and the weights are going to be on this side. And the reason why you do that, if we just continued with the telescope imaging down, it would run into your pier, run into your laptops, which are covered by that towel. So what we're going to do is flip it, and it'll be rising up then and following the target into the lower part of the horizon, or lower part of the sky, towards the horizon. Okay, we're going to be thinking about that 10:37 time when the mount flips, and we'll come back and look at that. I've scheduled to end everything at 1:32 when that's done, which will mean that my target will have fallen to about 30 degrees altitude. I don't want to image any lower than that. It's just too much atmosphere to shoot through, and the scene's so pitiful that I don't want to fool with it. So I'll stop it when it gets about 30 degrees, and that's really too low. But I don't have a lot of the Eagle's not going to be in the sky all that long tonight. All right, let's go back to we've got 2 images that have come in, and we're going to be finished with this now. Let's go over to the other kit, and we're going to be using a program, an acquisition software program called SharpCap. And my mount is connected, the camera is connected, and we don't see anything because there's nothing to see. I've got the exposure at 11.9 milliseconds, which is very fast, so there's no light coming in. If I raise the exposure up, we could see some faint. That's just 946 milliseconds. If I put it up to a minute or 2 or 3 or 15 or 20 seconds, we would have some light coming in. But there's no point. Let's now take our software called Carte de Sol. I can't pronounce it. I have connected my mount. I've gone up here and clicked on Connect Telescope. I already connected it, so it's tracking. It's actually in the park position, but I want to find Saturn, so I'm going to type it in here. Well, it finished it for me. And Saturn's really low in the sky. It's right here. So we're going to slew towards that. Now again, I'm using entirely different software to do this. But you see the mount slewing over towards Saturn, and we can go outside and take a peek at it. There it goes. See how low in the sky it is? It's barely going over our house, and let's see, it's 10 o'clock. It should be over the house, but it isn't much over the house. We may see the house. I didn't start last night till about 11:30. All right, I'm gonna find out real quick. That'd be a hoot. We may not be doing this. All right, let's see. We want to go back to SharpCap. Now let's go to let's start looping with PhD2, and let me bring this up. And let's see if we can't find, this has a wider field of view. Let's see if we can't find, speed this up. So this is my virtual hand controller, and let's move, I don't know why we're so far off. Usually, let's raise our exposure up to Say 1 second. We may be in the top of the house. I see stars at the let's move a little more west. Let's go back to Cartier de Sol. I can't pronounce that. Good thing I wasn't born in France. I would never be able to speak the language. Alright, let's see here. We want to go back to Saturn. We want to slew because I've moved off. Back to Saturn. Let's get back there again. Alright, now we're back. Let's see, we're back where we started from. Let's go move in the other direction. And let's go on up and change this to 3 seconds. Alright, let's try moving east. What we're trying to do is find Jupiter or find Saturn. You can sleep now without having to go outside and look through a finder scope. I'm using the wide field on top of the guide camera to do that, and that wasn't fine. That didn't work. So let's go back to Cartez. We'll get it in a second, as long as we're not in the trees. And let's slew back to Saturn. Mount's not moving. I'm going to try something just for the heck of it. I'm going to go to Jupiter. And that is low in the sky. Let's go up here and find Jupiter. And let's slew there. It's going to head over to Jupiter. Okay, let's go back. And you know what? Let's look at our daggone. Let's break right. We got our gain up. I tell you what's wrong. Hang on. Everybody's gonna have to hang on a minute. I'm gonna head outside. It's going to take me a second to get outside and make an adjustment. And I hope we don't have clouds, but at any rate, here we go. Okay. Guess what just showed up in the sky? Let me find my headset. You won't believe it. The cap was still on the guide camera. So my RMA friends, when you finally go to the YouTube channel and watch this, you'll get a good laugh. Cardinal saying always take the caps off of your cameras. All right, let me bring up the reticle and till I'm out of breath. Now I want to use the bullseye. There you go. And I want to move. I don't need to be moving it 3 times sidereal, and I want to move north. Let's change this to 1 second. And there's Jupiter and one of its moons right next to it. I meant to tell you that. We want to move it north. And I am really surprised I've got Jupiter this low in the sky. It's got to be on top of my house. And then I think we want to go west. Yeah. Let's go north again. And let's go west. That ought to get us close. Now let's bring up Sharp Cap. And there it is in Sharp Cap. Let me bring the gain down right now, and let's also bring down the exposure, and let's run the gain up. Let's run the gain up to about, it's gonna look real noisy, but I'm told by my RMA friend, RMA is Roper Mountain Astronomers in Greenville. Great organization. If you're around this area and you have an interest in astronomy, by all means you want to hook up with a place like that. And the Spartanburg Photography Guild also has some tremendous, I'm going to stop or change my field of view, or my region of interest. And let's put Jupiter right there, and let's go ahead and see if we can't guide. We'll start the finding some stars to guide on, and let's try going to 3 seconds, and let's go back to Sharp Cap. And we are looking at Jupiter, and I hate Windows. I don't know why these things pop up. Make them go away. And now I've got Microsoft. No, I don't want to end Sharp Cap. So it's looking pretty stable tonight, and one of the things that is hard sometimes to understand is that this is a reasonably good image of Jupiter. The way it moves around and bounces, that's just due to scene conditions, and the scene conditions are capable of changing throughout the night. As a rule, they get better the higher your target gets in the sky. If you're shooting really low to the ground, you've got atmospheric issues from thermal stuff coming off of the roofs of houses and highways, where it's just still emitting a lot of heat, and And but the higher up you get, it's kind of like you're shooting through fewer layers of atmosphere, and so it doesn't bounce around as much. I am not using an atmospheric dispersion filter. I do have one. I just don't have it on, but it will help to combat some of the porcine and some of the color aberrations that you're inclined to get with some kits. I don't really think it would make that significant a difference in this tonight, but I'm lazy. It would involve having to put it on and go back out and refocus everything manually first to get it within certain margins, and then I could do electronic focusing from the inside. So I'm just too lazy to do that. Down here's my histogram, and right now it's slightly brighter than 50%, and so what I would probably do is drag it down to where it's about 50%. You're going to say, well, it's off. Well, it is awful dark, but at 8.6 milliseconds it seems dark. But a good friend of mine in astrophotography who takes such awesome pictures of planets said to sacrifice that light to get a faster frame rate is critical for Jupiter because it rotates so fast. I think I'm going to go ahead though and lower the gain a little bit, say to 300 and 70, and I'm going to raise this up to get my histogram back there. And nope, I'm now at 52 frames per second, so I better go back up. I need to be around 100 frames per second, and in order to do that I need to affect the exposure time. If you have a long exposure time, then it's going to take longer to get the frames than if you have a shorter exposure time. So I'm going to bring it down some more till I get it to about 100. And then once I get it around 100, then I'm going to bring my gain up until my histogram is okay. All right, let's take. We're going to take a capture, and I'm going to start this capture at. We're going to do 10,000 frames. This is 10,000. This is a video that's 10,000. Separate files, video frames together in one AVI file, and I don't want to take an AVI file. I guess it's too late to change that. What I wanted to do is take. Hey, Dennis. Dennis Wild is a member of RMA, and he's has a cool observatory in his. He's kind of out in the country. He's got much darker skies than I have, and I've only seen it from pictures. But he's got one of the domes, and he says I'm imaging asteroids right now. So you're gonna have to show me how you do that. I think I could probably figure it out, but I sure like coaching. But at any rate, we're going to start with this 10,000 frame, and I'm just going to be an AVI file. And I'll go ahead and do this, and then when it's done I'll change this to a SER file. And that's as soon as we just get one of these. I'm really doing this for the video to kind of show you how I collect the information. Then I'm going to take you over to Saturn, because I think that's everyone's favorite planet of all the planets. The rings just have some magic. While I'm doing that, I'm going to go back to the other kit, and it's because it's going to take we're at 3,500 frames right now, and we're doing 10,000, so it's going to take it a couple of minutes to do it. So let's go over to our other kit, and let's see what our data is looking like. we're taking HA, hydrogen alpha, of the Eagle Nebula in wide field, and we can zoom up a little bit. It's noisy, but it's going to be noisy. It's hot outside, and I'm only cooling the camera by -15 below ambient temperature, so you know we got a 60 degree sensor, and these are long exposures. They're not really that long. I think these are 102-minute exposures, and then I'll take a little longer exposure, 2.5-minute exposures in sulfur and O3. I have the gain on this camera set at 139, which is unity gain for the ASI 1600 monochrome camera, and the offset is set to 21, so it's a gain of 139, offset 21. And so far we are working towards a 60 total pictures in HA, and then we'll go to the sulfur filter, and then to the oxygen filter. So let's go back now and see our 10,000 frames has oh heavens, I'm going to stop this. It's going to take a mess of them. I was taking this let's cancel. Let me show you what I was doing today. Earlier today I was imaging the sun, and I was doing a time lapse. So I have a series. I was taking 1,000 frame images of the sun every 15 seconds. So that was a time lapse. So I want to disconnect that. So it was taking another set. I just want this one. All right. Let's go see Saturn, and I'm gonna bring up my guiding software and stop it because I'm gonna start slewing. And let's go bring up Cortez de Sol, or Cortez Carte de Sel. And one of these days I'll have to ask my kids how to say it. They lived in France for a couple of years, but even if they told me, I couldn't get my mouth to work right. Alright, we're slewing over to Saturn. And there we go. We should be there, and let's take a look at the camera and see how low in the sky we are now. We can probably see it. We can probably see Saturn. Yeah, there it is. No, that's Jupiter. This telescope's a little bit higher, so that's Jupiter that we're seeing there. Okay, let's go to SharpCap. No, let's go to our guiding software, and let's start looping again. And there is Saturn, and it's a little bit Whopper John, so I'm going to clear out this guiding. That stuff just aggravates me, and I'm going to put this looping down to say 1 second, and I'm going to move them out north. I want to kind of get it closer to the bullseye, and then I'm going to come down west. Let's go north a little bit. I just happen to know that this guide camera isn't exactly centered, and that should get us in the ballpark. Okay, let's go back to find our target and let's raise the exposure. And there's Saturn. Scene's not real good, guys. You can really tell with Saturn, it's just kind of bouncing around here on us. We can image it anyway, but it is not going to be. It's not going to be great. I think it's better last night. Let me get my so I'm taking. I don't know if this is going to. No, I'm not. definitely going to raise the gain that high. Alright, it's going to have to be what it's going to have to be. I'm going to take my region of interest and make it much smaller. I don't need to photograph all the sky. That's a lot of sky that I don't need an image of, which will increase my frame rate some. Let's go ahead and I'm going to go ahead and guide, which will help keep Jupiter centered. So I'm using a software called PhD2, and PhD2 is sending these corrections to the mount in order to keep, let me get rid of this, in order to keep, hang on just a minute, in order to keep this centered, this star centered here, it's sending these corrections in RA and in DEC. The red line is the declination correction line, and the blue line is the right ascension. Theoretically, you shouldn't have a lot of declination corrections, because it's only moving in one direction and there's really no gear slop or backlash. But in RA, because it may move in one direction and then the other direction, you get these delays because of gear slop called backlash, and that makes guiding a little more of a challenge. And of course, if you have really good mounts, you don't have to worry about that, but you pay a lot of money for that. And the mounts that I'm using are just consumer mounts, like in the range that I would be able to afford, and anybody should be able to afford if this is their hobby. Okay, well, we got guiding going on. Let's go back and take a look at Saturn now, and we'll take an image or so of it. And so the guiding is going to keep Saturn right here where it belongs, in the center of my frame, so that the stacking lots just jump. Now, what I can't help is seeing conditions, nor can your guiding software. And your guiding is going to be affected by seeing conditions, and this is nothing you can do about it. Some nights the air is just better to shoot through than other nights, and when it is better to shoot through, your target just doesn't move. It just stays put. We can go ahead and put the mount to sleep. We don't need it any longer. And I'm going to go up here and I'm going to take a 10,000 started capture, and I'm going to take 10,000 frame AVI file. Let's take this, make this a SCR file. Boy, it's too late. They're both video files, and Josh Palmer with RMA was telling me the SCR file has more information in the log that is useful to use when you're trying to derotate these. Keep in mind that planets rotate, the Earth rotates, the Sun rotates, the planets rotate. And if you're imaging for any length of time, it's rotating on you. So it's hard to get a sharp image if your target's moving. Even if you've got guiding software that nails it dead center, if your target's rotating, well, you're going to have a blurry image. So you have to derotate the target, and that's done through software like WinJupos. And but the shorter your exposures, the better off you are, just to combat that. At the same time, you need a lot of frames to get the data so that you get rid of the noise and you have clear, colorful rings to look at, which is what everybody wants. Last night, I imaged these two planets. And the night, I think it was the night before, I think the last 3 nights. I know last night I did. Very cloudy. And the night before, I also imaged, and it was a much better sky. In fact, it was great seeing, but I had to get up really early, and so I didn't stay up late. I think we've got clouds, and nope, we may have in the other kit. Let's go to the other kit. I'm getting some noise telling me that yeah, we have some clouds. It lost the star twice, so it lets me know if there are issues with guiding. So there evidently are some clouds hanging around on the northeast. No, I'm south. No, I'm in the south as well. I'm in a little different part of the southern sky, but we're about to transit. We're going to transit in a few minutes. We're going to do a what's called a Meridian Flip, and let's bring up my, I think it's 1037. Let's bring up my software, and let's bring up my planning tool. Yeah, it's going to be 1037. So in a few minutes, what's going to happen is that there's 18 seconds left in this image, in this HA image, and it may take one more if it thinks it can squeeze it in. But if it doesn't think it will, then it'll just hold off and it'll start flipping them out. Yep, the next frame is too long, and so it's going to start a Meridian Flip. So let's go watch that happen. I'm going to bring up the software for outside. Let's log on, and without me doing anything, this mount right here in a few seconds is getting ready to move. So it's going to do a flip. These are Atlas Pro EQAZ mounts, both of them. And then the one that's covered is what I use for solar photography. And that's a Celestron AVX mount, advanced VX mount. So as you can see, it's just taking a different position, but it's needed to keep my telescope from banging into my pier. Or the case over here would have been to some of the laptop equipment that sits between the two piers. So right now what it's doing, it's recentering. I don't do a thing. It's plate solving now. And this is all done through the acquisition software, so it's going to go through the process of slewing to the target, then centering the target, and then picking up where it left off, taking pictures. Now, the orientation of these pictures, now that I've gone to the other side of the pier, is we're way off. We're 1,000 pixels off in RA and 271 in dec. So it'll continue trying to move the mount to where we're dead center, or we're within 50 pixel of error, total combined error. It fixed it. It's done. So it's starting the auto guider up now, which is the final step. So PixInsight has done its job. The auto guider is starting back up, and guiding is already started. And I'll just clear this out. We can start from scratch, and we'll clear this out. But we're in the guiding mode, so I'm assuming we're already starting to image again. No, we're down to 3 seconds, 2, 1, settling time. It's setting the HA filter. When it does a plate solve, it uses the luminosity filter, which is, I can take shorter exposures because you're not shooting through a narrow band pass. But we're already down to 106 seconds left on this image, so the mount has done what's called a Meridian Flip. It's oriented itself for the last or final stages of imaging, and it'll take another 13, finish at 60, then another 20, then these 21 pictures, 2 hours of imaging time left, and then it'll shut itself down, park the mount, and turn off the equipment. The Pegasus Ultimate Power Box, which controls the power and the data, will all shut down. Turn the dew heaters off, although I have it set up where the dew heaters are going to stay on all night, because I don't want to go out there and cover the scopes, but I don't want dew to form on my glass either. And so I'll keep the dew heaters on all night, or as long as they're needed, and that will be all night, because we know that the temperature and the dew point have intersected, which means you get dew. You'll get wet feet if you're out walking in the yard. Okay, back to Saturn, and let's bring up SharpCap. Saturn's right where it's supposed to be, in the middle, and we have finished that capture a long time ago. Let's take another capture, and I'm going to turn you guys loose, because you now know what I'm doing. You see my two targets, and when I'm finished gathering this information, I'll process it and post it, and hopefully I'll have it up on Facebook sometime tomorrow. I got a busy day tomorrow, doing a lot of sports pictures throughout the day. It's this time of year where I'm doing team pictures for different sports, headshots for football programs and things like that, because schools pick back up, and if COVID doesn't shut it down, it should be a pretty busy year. I do hope that everybody out there in that watches this either tonight or will watch it later on YouTube, I hope you guys stay healthy, have a good week, and COVID free, and if you have a chance to do any imaging up, I hope you get clear skies.